My name is Khalil.
Admittedly.
And welcome to the 8th week of the summer lecture series. So thank you for joining, everyone. My name is Tiffany Smith. I'm a M2 at Rutgers Robert Wood Johnson Medical School, and I'll be moderating tonight. So over the last 7 weeks, we've had the privilege of hearing from a number of distinguished guests on their research interests in the realm of sports medicine and musculoskeletal injury, and tonight will be no different. So we're going to begin tonight with our Summer Intern Journal Club presentations. And our first presenter tonight will be Miss Samantha Lopez Cruz. Samantha is from Keiser University. So Samantha, if you could please go ahead and share your screen with us, you can go and get started.
Okay, can you see my screen?
Yes.
Okay. Good evening, everyone, and thank you, Tiffany, for the introduction. My name is Samantha Lopez Cruz, and tonight I'll be presenting high concussion rate in student community rugby union players during the 2018 season, implications for future research directions, authored by Brown J.C. et al. Of all injuries common in collision sports, concussions have received the most attention due to the potentially negative cognitive effects in the short and long term. There is little research done on non-professional rugby players, even though they make up the majority of the world's playing population. This is the reason why the authors chose to investigate Stellenbosch Rugby Football Club, also known as the Mateys, the official rugby club of Stellenbosch University, which represents one of the world's largest non-professional rugby clubs. Thus, the aim of the study was to describe the contemporary concussion injury rate and factors associated with these injuries in this large cohort of non-professional student rugby players at SRFC. The cohort consisted of 807 participants who are all registered players of the residence rugby tournament at the university. Baseline demographics were obtained on the male student rugby non-professional players who registered for the 10-week-long 2018 season, which comprised of 101 matches and 2,915 exposure hours. All match-related injuries were captured by the medical staff of Stellenbosch Campus Health Service on an electronic form developed from the consensus statement for injury recording in rugby. However, the authors only reported on time loss injuries in the study. Body regions were captured by Osaiyekemwen code, but were further categorized into 4 regions used in the Williams et al. 2013 meta-analysis for comparison: head or neck, upper body, trunk, and lower body. During this 2018 tournament, there were 89 match-related time loss injuries at a mean injury rate of 30.6 per 1,000 match hours. On the assumption that each of the 807 players played a match, this is an injury proportion of 11%. Of the 4 body regions mentioned previously, the most frequently injured was the head or neck, which comprised 44% of injuries in these regions, at an injury rate of 14.4 per 1,000 match hours. In terms of specific regions as identified by the OSICS code, the 5 most commonly injured regions, which comprise about 90% of all injuries, were the head, shoulder, ankle, knee, and hand. The following 3 OSICS codes were reported by medical staff and grouped together for concussion: HNXX, HNCA, and HNCX. Collectively and irrespective of region, these 3 concussion codes were the most common overall diagnosis, with 27 participants and representing 30% of all diagnoses at a rate of 9.3 per 1,000 match hours. As you can see in Table 3, the most frequently recorded phase of play that was associated with concussions was tackling, which was 33% at an injury rate of 3.1 per 1,000 match hours, followed by accidental collisions that were not part of the tackle phase of play, which was 30% at an injury rate of 2.7 per 1,000 match hours. This was slightly different from the ranking of proportions for overall match injuries, where tackling, which is 28%, and being tackled, which was 22%, were the two most commonly reported phases of play. In Table 4 below, overall match and concussion rates were compared by level of play, which was the 4 leagues. The second league had a significantly higher overall injury rate in comparison to the third league, with an injury rate of 50 per 1,000 match hours. The concussion rates were highest for the second, with an injury rate of 13.3 per 1,000 match hours, and first leagues with an injury rate of 10 per 1,000 match hours, but the rates were not significantly higher than the third and fourth leagues. One possible reason for this seemingly elevated rate of head injuries in the study could be World Rugby's recognize and remove policy at the non-professional level, which has effectively lowered the threshold for reporting of concussions. Moreover, awareness and thus reporting of concussion could have improved as a result of fear of long-term neurodegeneration from concussions from empirical and popular media. In addition, this cohort's concussion rate is still substantially lower than has been described in amateur rugby league players. This could be related to differences in the game styles of union and league. League has de-emphasized the scrum and ruck phases of play, meaning that the majority of the game is comprised of tackling, and tackling is highly associated with concussion injuries. However, the study does have its potential limitations. As this is only a one-season study, it is difficult to know if this injury rate is a fair reflection, but ongoing surveillance in this cohort will be able to answer this. Also, the total number of matches was about half the normal number of matches due to severe drought in the Western Cape in 2017 and 2018 that affected field availability. Moreover, due to the South African private healthcare system that functions on a free-for-service model, it is possible that some non-concussion injuries were missed if a player opted to seek attention outside of the university medical service. In conclusion, this study found a high rate of concussion injuries in these amateur student rugby players, especially in comparison to this cohort's relatively low overall match injury rate. Nonetheless, these findings warrant the continued surveillance in order to monitor and ultimately reduce these injuries. This highlights how it is important to continue to investigate and improve on the effectiveness of concussion education programs. Finally, the addition of video surveillance to these matches may provide insight into factors associated with concussions in order to develop a targeted intervention for this cohort. Thank you.
Very nicely done.
So thank you, Samantha, for that great presentation. Does anyone have any questions? Or Dr. Lopez, do you have anything that you would like to add?
No, it was very well done. Very clear, and everyone, I'm sure, grasped the concepts.
Yeah, I completely agree. So if no one has any further questions, we can move on to the next presentation of the night, which will be by Ruth. So let me go ahead.
I'll share my screen. But to clarify, I've been having a little bit of technical issues in putting my PowerPoint into presentation mode, and I hope that doesn't interfere with the clarity of my presentation. I'm just gonna put it share screen.
Okay, well, so to give you a brief introduction, so Ruth is going to present next, and so Miss Ruth Ogbemudia is from Valley Stream North High School, and so yes, feel free to get started, Ruth.
Thank you.
And if needed, if there's an issue with your PowerPoint, feel free to send to me and I can project for you.
That's fine.
Okay.
Okay, so thank you for that lovely introduction, Tiffany. As she said, my name is Ruth Osaiyekemwen Ogbemudia, and today I'll be presenting an original research paper by Colin W. Fuller called Modeling Injury Burden in Rugby Sevens. So overall, this study aimed to develop a time-based model of injury using a bunch of mathematical equations in for Rugby Sevens team to demonstrate its utility. This was done in response to Rugby Sevens being a relatively newly included Olympic collision sport in 2016, and it is also played internationally, and it also has a very high injury incidence, as the next slide will show. Overall, they completed this study and made the kinetic time model to model injury burden based on the Sevens World Series injury data, and they also grouped this as a descriptive cohort study. So as mentioned before, Rugby Sevens has a very high injury incidence rate, and this has been confirmed by a bunch of literature, kind of ironically done by the author himself. As said on the slide, as a higher intensity with fatigue in later stages of the tournament, and it also has a very high injury burden, which creates a significant player management issue during many of the tournaments. Overall, this is why Fuller aimed to create a model to actively predict when and how injury burden will be higher and to contribute to preparedness and in overall injury prevention in international teams. And I have a little schematic here. The high injury incidence in the Sevens World Series provided a really good opportunity to test out a novel model which could create a precedent in sports medicine. So the methods, firstly, I want to address the population. The population used was a bunch of professional Rugby Sevens players. Specifically, they used a cohort of men's international Rugby Sevens teams from European countries such as England, Scotland, or Wales over the period from 2008 to 2016. They defined injuries according to the consensus statement, and they assumed first to input into the mathematical model that a team would progress to the final stages of the SWS tournaments, which translates to about 6 games in each tournament, and about 20 players would undertake about 1.5 hour training sessions on tournaments on non-tournament days, or days where they didn't have any games. This is the novel kinetic model defined in terms of derivative and just basically in simpler terms, mathematical models. So the variables they had was N injured, N uninjured, and K injured, K injury, and K recovery. The K variables represent rate constants, which are associated with the rates at which players sustained or did not sustain injuries or just recovery. And the N injured is the number of player injured with respect to time. And N uninjured is the same thing, except the players are not injured. And it's in respect to time because injuries depend on time in this model. Overall, there are 2 parts to the results, which is the actual injury surveillance part and the kinetic model. This is the injury surveillance results. So a total of 855 match injuries resulting from 7,875 player match hours and 34 training injuries resulted in 37,389 player training hours. Overall, the average injury incidence was about 108.6 according to a 95% confidence interval, and training injuries was significantly lower, being 9.1, also in a 95% confident interval. As for the kinetic model, overall, the total injuries were kind of aggregated together, it showed as the seasons as the season progressed, the total number of injuries increased, which makes sense because as mentioned before, Rugby Sevens is a very high intensity sport. And also it showed moderate accuracy, as you could see the lines of the kind of peaks and crests match up together. Going on to the discussion, since this model, as shown by the graph, performed moderately okay, the author felt that it could be used as an important new support tool for governing bodies to conduct risk assessment, and overall just foster better injury prevention practices. Also, it's important to note that the kinetic model describing a team's injury burden was also made in Rugby, it was made in Rugby 15s, but it performed well enough to be the basis of this study. They also cited the unique benefits could include, but are not limited to, quantifying injury burdens throughout the season, and overall just investigating the likelihood of certain changes being implemented, such as changes to match and training schedules and changes to injury prevention strategies. It's also important to note that certain limitations exist in the study. As I mentioned before, they use men's international teams, but they left out women, 50% of the population, and that should obviously be included in the study. And they only included the specific time of the tournaments, and even although they included like the not tournament, like the training days, they did not include other factors that could contribute to injury burden, such as player illness, family commitments, and other rest periods beyond those not included in the training hours. Overall, despite all the limitations, the model does provide a good means of developing a deeper understanding of the demands placed on teams, especially in Rugby 7's international competitions in regards to the scheduling. And it could also be potentially used for individual team to model how much injuries they really sustain. It can also be used by coaches to forecast and manage the likelihood of injury burden. And that's the end of my presentation.
Thank you so much, Ruth, for that very well executed review. Does anyone have any questions or comments for Ruth?
I have a quick question. Ruth, could you go back to the model that you put up, the kinetic? So, yeah, on this figure, can you just re-explain? They're lining up together well, which is suggesting that the model works well.
Mm-hmm. So as you can see here in the key, there's all match injuries, training injuries. So it's basically, because typically match and training injuries show the same injury pattern. So when they're lining up well, it shows that the model is actually taking into consideration both like training periods, since they have such a similar pattern. For example, if the dotted line was like all over the place, it wouldn't necessarily like make any sense, because the author said that the training patterns and the match injury patterns were the same, and that boosted their results. Although in other mathematical like models, they do include like an accuracy score, it was not cited here. It was probably because it wasn't directly related to machine learning. It was just like, as I'll just go to the other slide, it was literally a mathematical model. Like there was no, wasn't like a software. Oh, what?
Yeah, there was no software involved, the machine.
Yeah,
It was
so
actually hand calculated.
Yeah. So I hope that answered your question.
Yes, it did. Thank you.
Okay. Does anyone else have any like other questions? Sorry if I went a bit fast.
No, not at all, Ruth. And since you're on slide 8, I'll comment on this. So, does everyone understand what they're doing here? And what Ruth is alluding to is that the dark line peaks almost reflect the lower line dotted match peaks. Basically, you just add on the training injuries and make the overall injury rate, which is therefore you can calculate your overall injury burden. And so that's how they've calculated. Again, you can do injury burden analysis with match and training, or overall time loss and medical attention injuries. Basically, there's varying models on how to calculate the burden overall. But if you're looking at the way we're looking at it, matches in tournaments, then you can do the overall burden for the tournaments themselves. But again, this is all very much an analysis that's been used in other studies and other sports, and now they're applying a lot of these in the rugby world. Again, Dr. Barr came out with a burden paper emphasizing it in their sports injury prevention potential. But again, prior to that, Dr. Van Mechelen alluded to the fact, again, we've spoken about his early papers in the early 90s that gave up the sports injury prevention model. But again, very unique that they're bringing it out and looking at it this way. It is a limitation, but then in Dr. Finch and Tui's paper, they compared the burden between men and women. Now, again, Dr. Fuller compared the incidence of injury between men and women in the Rio Olympic paper, but they didn't compare the burden per se. Okay, everyone?
Thank you. Are there any more questions before I unshare my screen?
So, okay, if no one has any further questions for Ruth, that concludes our summer intern journal club presentation. So thank you, Ruth and Sam, for those presentations.